All right, y'all. So 6.1 support is getting us ready for our 6.1 college algebra. So 6.1 support deals with radical expressions. And the thing we'll be doing in support is looking at the domain of a radical expression. So a radical expression has a radical, and then the A under the radical, we call that the radicand. Now, the thing about radicals, remember, the smallest number I can take the square root of is 0. If I try to take square roots of negative numbers, those gave us imaginary answers. So when we're looking at the domain, the radicand, which is A, this A has to be greater than or equal to 0. Okay, if this value is negative, then that's when we're going to run into problems with the imaginary answers. So for the domain, when we find a domain of a radical expression, first thing we do is we set that radicand greater than or equal to 0. Next, we'll solve it for the variable. And y'all, once I solve for the variable, I'm then going to write the answer in interval notation or set builder notation. Now, here's the thing. If you're writing in an interval notation, so in interval notation, we're going to use brackets around a number. And the reason we use brackets is because of that equals part on this, okay? So if there's an equals in it, we use the brackets. That includes that number, okay? So we use the brackets around a number. And depending on which side, if the number's first, I'll use the left bracket. If the number's the last thing in the interval, then I'll use the right bracket. Now, we still use the curvy parentheses around infinity. So if you got negative infinity or infinity, we use the curvy parentheses, okay? Now, set builder notations, that's when they give us the little fancy parentheses, and they'll have an X such that X is like greater than or equal to some number. So set builder notation, we just basically will put our answer in here. Interval notation, we'll use our brackets and parentheses. So let's do there's 3 of these in support. So I'm going to knock out these 3. So they want us to find the domain. Now in support, we're going to write the answers in interval notation. Now I think there's one of these in the college algebra part, and they write their answer in that one question in the interval note in the set builder notation. Okay. Y'all, we're going to find the domain. The first problem is f of x equals the square root 49 minus x. So the 49 minus x is my radicand because that's what's up under the radical. So I'm going to set 49 minus x has to be greater than or equal to 0. And then we're going to solve this, okay? So y'all, to solve this, I'm going to subtract 49 from both sides. So that cancels on the left side. That leaves me my negative x. Greater than or equal to, and on the right side, we get what, a negative 49. All right, y'all, so now we're going to divide both sides by -1. But remember, when you divide an inequality by a negative number, we got to reverse that inequality. I'm going to come in, divide both sides by -1. But my inequality will go from greater than and equals to a less than and equals. And y'all, that's the only time you got to worry about is when you're dividing these inequalities by these negative numbers. So I end up with a positive x less than or equal to a positive 49. So 49 minus 49 gives me my 0, and the square root of 0 is 0. But if I put a number in here bigger than 49, like 50, 49 minus 50 gives me a -1 under the radical, which makes that imaginary. So 49 is the largest number we can put in it. So that means 49 has to be on the right side of our interval. Now, x has to be less than that 49. So anything less is coming in off this left side over here. So we say that it's coming in from negative infinity. And remember, infinity always has a curve. So our domain would be from negative infinity to 49, including that 49, okay? All right, y'all, my second one, let's see, we're going to have f of x equals square root x minus 5. All right, so remember, my radicand is the x minus 5. So I'm going to set x minus 5 greater than equal to 0. So y'all, looks like we just got one move on this one. We're going to move that -5 by adding 5 to both sides. So bring down our x. That cancels on the left side. And then 0 plus 5 gives me a 5. So this is telling me that x has to be greater than or equal to 5. So 5 is my smallest number. So 5 will go first on this. And then greater than 5, anything headed out toward the right, we say is headed towards positive infinity. And y'all, I'll show you a trick on this. This one points left, so that means it's going to start at negative infinity. This one's pointing to the right, so that means it's going to head towards positive infinity. So these little inequalities will point at the infinity stuff, okay? All right, y'all. F of x equals 10 minus x. So y'all, what is the domain of f of x equals 10 minus x? And I'll let y'all play with that one. This was sort of a curveball, okay? So y'all, let me ask you this. There's no radical on this one. And there's no fractions on this one. So if there's no fractions and there's no radicals, our domain is all real numbers. Okay, so this is just a curveball they threw at you, just to see if you were remembering that the only two things we're worried about are fractions and these radicals. Well, y'all, there's nothing here, so that means no matter what number I put in for the x, I will get a real number out of this. So this one will work for all real numbers, which is negative infinity to our positive infinity. So they'll still throw some of these at you just to keep you honest on your domains, okay? All righty, y'all. So let's move into the 6.1 college algebra. So let me get my camera back up. All righty. So 6.1 college algebra deals with radical functions. So there's one domain problem, and then we're going to look at graphing these, okay? So the first one says determine the domain of the function. Use set builder notation. All right, y'all. So they're giving us f of x equals a square root 3x minus 5. All right, so remember, we know that this 3x minus 5 has to be greater than or equal to 0. So we're going to come in and set 3x minus 5 greater than or equal to 0. And so now we just got to solve this for the x. And once we get that x, we will set it in set builder notation. So y'all, start by adding 5 to both sides. All right, so that's going to give us 3x greater than or equal to 5. And then come in, divide both sides by 3. And notice, since I divided by a positive number, I do not reverse the inequality. Only when you divide by negative numbers. So y'all, the 3's cancel, giving me x greater than or equal to my 5/3. So for set builder notation, they'll give you A, B, C, D. So on this one, we want the one that has x such that x is greater than or equal to our 5/3. So pretty much whatever answer you get here is the answer you're looking for when you look at your set builder, okay? All right, y'all. So Let's play with a few graphs here. So we're going to graph f of x equals 5 times the square root of x. Now I'll do these by hand, but the calculator will spit these out pretty quick, and I'll show you that. So y'all gonna pick my x's and y's, and then I'm gonna come over here and graph that. Oh, and let me go out about 5 or 6 on this. All righty. So the first number I would probably pick is the smallest number I can take the square root of, and that would be a 0. So let's put a 0 in. Square root of 0 is 0, and 0 times 5 gives me a 0. Now, y'all, here's the thing on this. Since I'm taking square roots, I want my x's that I put under here to be able to be taking those square roots. So the next number I would probably pick would be a 1, because I can take the square root of 1. So if I put a 1 in here, square root of 1 is 1, and 1 times 5 will give me 5. Then, y'all, my next number I would probably pick would be a 4. I would skip 2 and I would skip 3 because they don't have square roots. Okay. There's not a number times itself that'll give me 2. There's not a number times itself that'll give me 3. So the next number I picked was 4, because if I put a 4 in here, square root of 4 is 2. And that 2 times 5 will give us a 10. So be picky about what numbers you're putting in under these radicals, because you want this radicand to always equal a perfect square so that you can bring that number out. All right, y'all, so 0, 0 would be here in the center. 1, 5, I go right 1 and up 5. And this one would be 4, 10. So over here at 4, it's already shooting up here to about 10. So that this graph will sort of come up and curves to the right. So let me show you how to graph this one. So I'm going to share my calculator. All right, y'all, I'm going to go to y equals. And I had 5 square root of x. So I'm going to push my 5. The square root is the second blue button and the x squared button. And then underneath, I'm going to put my x, and then I'll arrow out of that. So let's look at the graph. So there's our graph shooting off to the right like we had. Now let me show you the table. So you see them negative numbers are giving me errors under there because those are giving me imaginary type answers. But 0, we put 0 in, we got a 0 on ours. We put a 1 in, we got a 5. But y'all look, if you use 2 and 3, you got decimals. So 4 would have been the next perfect square, and that gave me a 10. So let's see, the next perfect square after 4 would be 9. So that means 5, 6, 7, and 8 are all going to give me decimals. But when I hit 9, since 9 has a square root of 3, 3 times 5 gave us 15. So be picky about your numbers on these radicals so that you don't end up with all these decimals, okay? All right, let me put that back to 0. So y'all, graphing's not real bad. You just got to keep up with what you're throwing under your radicals. All right, so let's graph another one. We're going to graph f of x equals -2 square root of x. So remember, these negatives, when you got a negative in front of your function, that's going to flip the graph over the x-axis. Okay? So let's graph this one and see what happens. Oh, and I'll start out about 5 again. All righty, so there's only an x under here, so the numbers we're going to pick would be 0, because that's got a square root, 1, and then I'll pick a 4. All these numbers have square roots when I put them under that radical. But putting a 0 in, square root of 0 is 0. 0 times -2 is 0. So y'all, my first point is sitting here in the center again at 0, 0. I put a 1 in there. Square root of 1 is 1. 1 times -2 gives me a -2. So over here at 1, we're down here at -2. So see, that negative is going to make all these positive y values negative now, okay? So we put a 4 in. Square root of 4 is 2. 2 times -2 would give me a -4. So y'all, over here at 4, we're down here at -4. So that this graph is going in the negative direction. Okay. And y'all, they're not too bad. Just keep up with what kind of numbers you put under the radical. So let me change it up. Instead of putting an x under the radical, let's put a square root of x minus 2. All righty, y'all. So let me get this ready. And y'all, and I'll tell you on these, you're not going to have to physically graph these in math labs. They'll give you pictures, and you'll look at the pictures that match what graphs you're getting, okay? So on this one, I'm probably not going to pick a 0, 1, and 4 because of that x minus 2. So if I want this to equal 0 under the radical, the first x I'm going to pick is going to be 2. Because 2 minus 2 gives me 0, and the square root of 0 is 0. So I'm just going to find x's that make these equal these kind of numbers over here. So if I want this to equal 1, then x will be 3, because 3 minus 2 gives me 1. So 3 minus 2 is 1. Square root of 1 is 1. Now, if I want this to equal 4 under here, because 4 is the next square root that I can take, if I want that to equal 4, I'm going to make this x a 6. 6 minus 2 is 4. Square root of 4 is 2. Let me ask y'all this. This was one of our things we did in 7-2. When you subtracted 2 from the x and it was under the radical, remember, that's going to move me left or right. So since we're subtracting 2 from the x, it should move me to the right 2 units. So y'all watch what happens when I plot these. First point 20 is right here. So see, it's not starting in the center no more. It's shifted it right 2 units. And then 3, 1. And then over here at 6, 2. So by subtracting 2, it moved my basic graph right 2 units. And then y'all, let me show you on the graph on that one. So let me go to y equals and clear this. So that was a square root. So second x squared of a x minus 2. All right, let's look at the graph. So notice it did like we did. It moved it over 2 units to the right. And then look at your table by hitting second graph. So see, now I couldn't use 0 because 0 minus 2 made that imaginary under the radical. Couldn't even use a 1 because 1 minus 2 gave me -1. So the smallest number I could use was 2 on that one, okay? And then see, I used 3, got a 1. 6, I got a 2. So let's see, next, we would have had to use 11 because 11 minus 2 would have made that a 9 under that radical. Well, y'all, so I just wanted y'all to see that on the radicals, you want to be picky about the numbers you're picking because you're trying to take square roots of these numbers, okay? And yo, that's what's nice. We got our calculators on those. So when in doubt, graph it on the calculator, and you're going to pick one of those 4 graphs that match those. All right, so that's your 6-1 stuff, dealing with the radicals. So now we get into 6.8. So 6.8 deals with increasing, decreasing. Now we've already played with increasing, decreasing, and constant. But this is the college algebra part going through it, okay? And then we're going to look at piecewise functions. I'm going to start out with the piecewise functions, and then we'll play with the increase and decreasing, okay? So have any of y'all ever experienced a piecewise function?
What is that?
Yeah. So let me give you my definition, and then I'll sort of show y'all a case that I'm pretty sure y'all have seen one. So y'all, a piecewise function is a set of equations in which the domain determines which equation is used to evaluate it. And I say probably most of y'all have dealt with piecewise functions. You just didn't know you was dealing with a piecewise function. So an everyday instance where I can think of y'all using piecewise functions, do any of y'all ever work a job by the hour?
Yes.
All righty. Now, if you work 40 hours, you got your money per hour. But if you worked overtime, you got time and a half, right?
Yes.
All righty. So that's an example of a piecewise function. Because let's say I'm going to call my function P of T, where P is your pay and T is your time in hours. So this will be a formula for the amount of pay. Now let's just say the person I'm using made $15 an hour. So if you make $15 an hour, your pay is going to be 15 times the T, which is the number of hours you worked. But y'all, that's only good up to what? 40 hours, right? So this means that your T has to be less than or equal to 40 hours. But if you get overtime, your formula would be 600. So 600 is 15 times 40, which would give you 600. Plus, you would make $22.50 an hour for T minus 40. So what this means, if I work 45 hours, 45 minus 40 would give me 5 hours at my time and a half, plus my 40 hours of $15 an hour. Now, I would use this formula if my T was greater than 40. So y'all have all done this, right? You figured out what your pay would be if you made 38, 39, 40 hours. Then you knew if you made overtime, you had time and a half, and you multiplied that by how many hours overtime you had and added that to your regular paycheck. So that is a piecewise function, and it depends on this domain back here, whether my hours are less than or equal to 40 using this equation, or whether my hours were over 40 and I used my second equation. So some examples of what they ask you in MATLAB, which equation would we use for P of 35? So they're saying, hey, if I want to find P of 35, which is 35 hours, would I use the first equation, 15 times T, or would I use the second equation with my 600 plus 2250 times my T minus 40? So y'all, would we use the first equation or the second equation?
You're gonna use the first equation.
First equation. So we would use our 15 times T. Okay, so that's what they're going to hit us with. They're going to give us a system of equations, and we're going to figure out which equation we would use to find our values. Now, if I wanted to know what I get for 35 hours, I would plug my 35 into that T, multiply, and see what I get. So I'm going to do one, and then we'll play with these on MATLAB, okay? So, which equation would we use to find f of 7? So y'all are giving me f of x equals Now this one has 3 equations. It equals x minus 4 for any x which is less than -4. We use the x squared equation for -4 less than or equal to x less than 3. And then we use 7x for any x that is greater than or equal to 3. So y'all, would we use the x minus 4 equation, x squared equation, or the 7x? So is this 7 less than -4? Is it equal to -4 less than 3? Or is it greater than or equal to 3? So y'all, which equation would y'all use?
The third one, greater than or equal to -3 or to
Yeah.
3.
So 7 is greater than or equal to 3, so I would use the 7x equation. All right, so we're going to go to Math Lab, do some of these, and then we'll play with our intervals, okay? So let me share my screen. All right, you also notice what they got. F of x equals x minus 4 for x less than -3 equals x squared for -3 less than or equal to x less than 1. And then it equals 6x for x greater than or equal to 1. So to find f of -7, would y'all pick A, B, or C over here? I can't tell if I'm hearing answers. I'm hearing something, but I can't tell what it is.
Is it x squared?
Okay, so is that -7 to be x squared? Is -7 in between -3 and 1?
Okay, no, then 6x.
And then let's
Because
see.
no, the -7 isn't in between -3 and 1.
Right. So is -7 greater than 1?
No, because
No,
you're
it's
going to the
not.
left side.
It's gonna
Well,
be
then
X. It's
it
gonna
has to be x minus 4 then, don't it?
Woo, today must be another Monday or something.
Well, for y'all, it is like a Monday because y'all are on a Tuesday. Okay. So yeah, x, since that -7 is less than that -3, we would use that x minus 4 equation. Okay. So let's see what y'all do on the next one. Because there's going to be like 3 of these in a row. So you're finding f of 14. Okay. 14. So it's either x squared if that 14 is less than -2. It's going to be x minus 5 if that 14 is equal to the -2 and less than 3. Or it's going to be 4x if that 14 is greater than or equal to a +3. So y'all, A, B, or C?
It's gonna be
A.
A, definitely, because that 14 is bigger than 3, so we would use the 4x equation. There you go. All right, so this one you're finding f of 3. So it's x minus 6 if my 3 is less than a -5. It's 9x if -5 is less than or equal to my 3 less than 3. Or it's going to be x squared if my 3 is greater than or equal to 3. So y'all, A, B, or C?
It's gonna be C.
C, because of that equals on it, right? So notice to be 9x, it would have to have an equals under that, but it don't. It's got the equals under the x squared equation. Good job. So that'd be x squared. And check that. All right, so y'all, next I'm going to play with some of these interval notations. So let me pull one of those up, and I'm going to make this a little bit bigger. So we're going back to the increasing, decreasing, and constant intervals. Now, when I look at the intervals on whether increasing, decreasing, and constant, I only want x values. I don't care about any y values. All I want are the x values where it's going down, up, or straight across. Now, y'all, let me show you. This left side, although the left side of this has the arrow here, that ain't the direction it's going. That arrow just means that this line is going on forever to the left. And the same thing on the right. That just means that that line is going forever to the right. When you read your intervals, you want to read the graph going left to right. So start on the left side and read everything to the right. So there's one section on this where it is increasing, and that's going to be this third part over here where it's going uphill from left to right. So what I want to know is, what interval is this increasing? So y'all, it starts increasing right down here where my cursor is. So I'm going to go on the x-axis and figure out what that x value is. So y'all, let's count over. It looks like it's 1, 2, 3. So it looks like I'm at 4 on the x-axis when it starts going uphill. So from 4, I'm going uphill as I head out to the right. So we say we're headed out towards positive infinity. Now, when we're doing the increasing, decreasing, and constant intervals, we always use the curvy parentheses, okay? So from 4 to positive infinity, I'm going uphill, so we would pick B on that one. And then we would check our answer. So y'all, I'm going to let y'all have this one. What interval is this thing constant on? So where does it start being flat and where does it end being flat on my x's?
C.
It's gonna be -4, 4.
So -4 to 4. Good job, because it stops going downhill at -4. And as I go all the way across to that +4, it's flat. So -4 to 4. All right, y'all, that left side that's going downhill, from where to where is that one going downhill?
Negative infinity to -4.
So negative infinity, -4. So, ooh, that's A right there, right? Good job. So after you got good on that one, look here, they pop up. A crazy looking one. All right, so that's big enough now. So they want to know what intervals is this increasing. And if you go left to right, there's this piece right here. The second piece is going uphill. And then this fourth piece uphill is going uphill also. So let me start with the one on the left. This bottom point right here. Let's see where this one is starting on that x-axis. So y'all, what is that? 1, 2, 3.
-5.
So it looks like -5. And it's going uphill until I hit this x value right there. So we're right on the y-axis. So that means what? X is 0 right there. So we got -5, 0 for the first interval. Then we got to go to this second one here. So right here at the V, let's go straight up and see what that x value is. So y'all, that's what?
6.
Is that 6? Yeah. 6, and it's going uphill as I go through 7, 8, and looks like that and stops at 9. So y'all, let's see. We got -5, 0, and 6, 9. So that looks like C over here. So y'all all with me on these? We don't care that the Y values were -8 and 7 and all that. All we cared about was what intervals on our x-axis that it went uphill.
These was kicking my tail Thursday whenever we did the little support or whatever it was on them, because I was still worried about the Y values.
Yeah, and that's the main thing. Once you get fixed on that Y and X thing, then they're not too bad. But yeah, I used to do like you. I'd be like, okay, this thing looks like it's starting up here at 7 or so when it's going down to negative something. But they didn't care about the values. They just wanted to know on what X intervals did it go uphill or downhill or whatever.
Right, which X and where it was going to.
Exactly. So like this one going downhill is this third little piece here. So let me see where it starts and go down to that x-axis. Yeah, you can almost erase the Y stuff because you're only worried about the X. So y'all, where's that in the start at? Let me see. That looks like what? 1,
3 to 6.
2. So it looks like 3 for sure. Let me put my 3 in. And then you said, let's see. Yeah, 6, because that's where that other one started. So 6 has to be where that one ended. So from 3 to 6, we're going downhill. Constants off. So constants, this little piece going straight across. So y'all start me on that one and finish me on that little straight across first piece there.
-8 to -5.
So -8. Oh, perfect. That looks like, yeah, -5. Good job. So see, not too bad when you're focusing on your X's, are they?
Yeah, after Thursday getting my ass kicked in that one lesson.
I heard that. Now, some people like this one and some people hate it. So increasing, notice the very first section, although that arrow's going downhill, that line's going uphill left to right. So we got that section right there. And then we got this real steep section almost in the middle here. So let's start with the first little section, the part that goes up to the hump. That thing's coming in from the left. So on these, you actually got to put your own parentheses. So it's coming in from the left. So y'all, that thing's coming in from -infinity. And then I got my comma. And it's increasing until we hit where the hump is. So let's see, what's that X value?
-6.
-6. And then we close those parentheses, comma, and we're going to open our second set of parentheses for this little steep piece. So right down here, after it goes from the flat line and starts going uphill, I'm looking up, and that looks like it starts at, is that -1?
Yeah, that's -1 and 0.
And 0, because it ends right. So that's pretty steep. But yeah, that ends at the 0 on the X's. So we would check that answer. And then let's see, decreasing. And y'all, we've only got one part where it's going downhill left to right. And that's the right side of the little parabola hump there. So let me start my parentheses. So where does that start going downhill on your X's?
-6
So -6
to
until
-4.
until I hit, yeah, that's perfect because that stops at -4. Good job. And then and that was it on that, right? Just had one part going downhill, so check that. All right, y'all, so constant. And look at that. We got two constants. So how about this first one on the left side? What intervals is that thing constant?
-4 to -1.
So -4 to -1. And then we'll start our, okay, that's perfect. And then how about this last little section up here? Going straight across on the top.
And 0 to +infinity.
0 to +infinity. Perfect. Well, y'all sure better at them than y'all were last week, ain't you?
I know that's right.
And then let me think. I think that's all I was going to do with y'all, because oh no, I'll just show y'all a few. I got a few minutes left, so let me play with this with you just a second. So a relative max and a relative min are like mins and maxes, but there can be more than one on a graph. Sometimes they go uphill and downhill. So on this one, would y'all say this one had a relative maximum or a relative minimum?
A maximum.
It's going to have a relative maximum. So you would click that box and check that. And then it says the relative maximum occurs at what X value? And y'all are giving us that point there. So I can't read that first number. Is that a negative?
6.5.
So negative 6.5 is the X value. And then it has a value of, what's that Y value?
3.25.
3.25. So you would come in and answer that. Check that. Then it says, what interval is it increasing? So what interval is my graph going uphill? So it looks like this was coming in from the left, from what, negative infinity?
Negative infinity to negative 6.5. So C.
So C, perfect. And really, once you got that vertex point, that's the X value for your intervals, okay? So then they're going to say, well, hey, where's this thing decreasing from? What y'all picking, A, B, C, or D? It looks like
Is
it's
it C?
Let's see, is that what, negative 6.5 all the way to infinity? Perfect.
Okay, so it was these ones that was getting me, because if the line was like on the negative side, I was wanting to say that it was still going to, yeah, negative. And I thought it was still going to negative because it was on that side, but it was just going down.
Well, yeah, but remember, it started at that negative 6.5, and it's going downhill as my graph goes to the right on the X.
Towards the right. That's where I was confusing myself, because to the left is negative, to the
You
right.
see, it's going downhill, but that thing's going to go downhill forever and ever. So eventually it's going to get on that positive side and start heading towards those positive infinities, okay? So let's see, you check that. So y'all keep on going. Let's see how y'all do here. Let me make this one bigger. Now we'll say, you see how this one's got two humps? So it will have a relative maximum, and it's going to have a relative minimum in the valley. So look what they want first. They want the relative maximum. They want to know what is the maximum value, and then what X value did that happen. So we're looking at this little hump right here. And that
-4, negative.
But remember, they want on this one, they want the value first, which is your -1. And then that happened at the X value of, what did you say, -4?
Oh no, I said the whole point, Mr. Rathbun. So they
Mhm.
got us on that one because they just asked for the maximum.
Right. So on that one, you just want to, and just watch out for the order, because remember, while ago they wanted the X first and then the value. This one wants the value first and then the X. So y'all would check that. Now, what about the relative minimum? That's the little valley here. What is the minimum value and at what X value?
-19, X value of 2.
-19, and you said X value of 2, I think you said. Yeah, I can't tell that 2 is on the line on mine. All right, so check that answer. Good job. So y'all, here we go. We're going to ask you, where is it increasing? And y'all notice there's 2 spots where this is increasing. The first little uphill part is coming in from -infinity until you hit what X value?
-4.
Okay, so we need, oh, there's 2 of them with that answer. So we need to go to the second part and see what X values it's going from. So the second part starts at that little valley there. And what did we say that X value was?
2.
2.
To
So it's
positive
going from
infinity.
2 towards positive infinity, right?
Yes.
So 2 to infinity, we would go with what? D on that one. All right, then we would check that answer. And then what makes you click 3 times? So there's only one piece decreasing, and that's that little part going downhill in the middle. So y'all, A, B, C, or D?
It's gonna be A.
So let's see, -4 to +2. Good job. All righty, y'all. Let me see if I can make this one bigger. Now, this one, I think all we got to do is just figure out. I don't think we have to actually find the increase and decreasing. We just got to find out what this little maximum point is and what this little minimum point is. So our maximum point looks like a value of 1. And that X value is what, 0 right there? Because it's on the Y-axis, right? So our maximum has a value of 1 at X equals 0. So y'all, looks like we got 2 choices that they're giving us a 1 at X equals 0. So it's either going to be A or D. So now we got to look at this little valley over here and see what that point is. So that point, that Y value is looks like -3. And the X value is that 2. So I need 1 at X equals 0, which was A or D. And then I need -3 at X equals 2. So A said it didn't even have a minimum, so it has to be D on that one. And I think all you do is just pick that on these and check your answers. Well, let's see, what's this? Hell, we might as well knock out these last 2 then. What do y'all think?
Yeah, let's do it.
And then y'all be. So let me write this down and show y'all what they want. So they want me to find G of -7, G of 2, and G of 4. And they're giving us G of X equals, oh, at least there's only 2 equations. So it equals X plus 7 for any X less than or equal to 2. It equals 6 minus X for any X greater than 2. So I'm going to go to my pad for this and show you how I would work these. So to find g of -7, I got to figure out, is -7 less than 2 or is it greater than 2? Well, -7 is less than 2, so I would use the first equation. So g of -7 will equal the first equation, and we'll put that -7 in for the x. So that's going to give me -7 plus 7, which is 0. So g of -7 equals 0. Then you would come in and find g of 2. So 2, is it less than or equal to 2, or is it greater than 2?
You're gonna go with the first one, x plus 7.
So I'm going to use x plus 7, and I'm going to put my 2 in for the x. And y'all, 2 plus 7 would give us 9. So if it's got the equals, use the equation with the equals on that number. And then g of 4. So g of 4, is it less than or equal to 2, or is it greater than 2?
Greater than 2.
2.
So we would use the 6 minus x. So that'll just be 6 minus 4. And that'll give us a 2. So what do we get? 0, 9, and 2. So you would go put them in on your answers. So we had a 0. Check that one. We had a 9. Check that one. And then we had a 2. Check that one. So the trick on these is to find what interval it goes into and then put your number in. Ooh, y'all look, this one's got 4 of them on it. I mean, four numbers they want. H of -8, H of 1, H of 2, and H of 5. And they're telling us H of x equals -2x minus 18 for any x less than -7. It equals 2 for -7 less than or equal to x less than 2. And then it equals x plus 5 for any x greater than equal to 2. All right, y'all. So I got that wrote down. Let's see what we do. So for h of -8, are y'all using the top equation, middle equation, bottom equation? Is
Top.
okay, I heard you.
The top equation.
Yeah, -8 is less than -7. Good job. So we use the top equation. So that would be -2 times our -8 minus 18. So y'all, let's see. Negative times negative, that's going to give me what, a positive 16 minus 18, which would give us a -2. All righty. H of 1. H of 1, am I using the top equation, middle equation, or bottom equation?
The middle.
So the middle, because 1 is in between a -7 and 2. And y'all look at this one. This one don't even have a variable. This one tells me that any number in between -7 and that 2 equals 2. So this would be like the horizontal line going across. All those values would equal 2, okay? All right, what's next? H of 2. All right, y'all. So H of 2, top equation, middle equation, or bottom equation?
The bottom.
The bottom one, because of that equals, good job. So that's x plus 5. So that's going to be 2 plus 5. And y'all, that'll give us a 7. So finally they said, how about h of 5? Top, middle, or bottom for h of 5?
The bottom again.
The bottom again. So that'd be what, 5 for my x plus 5. And that'll give us a 10. So y'all, that's we're gonna put them in real quick. All right, so h of negative 8, y'all gave me a negative 2. H of 1, we got a positive 2. H of 2, we got a 7. And then H of 5, we got a 10. So y'all, these aren't bad if you pick out the right equation to use, okay? So figure out where your number fits on those domains. Once you got the right domain, plug it into that corresponding equation and get your values out of those, okay? All right, so I'm going to stop my share. So y'all, 6-1 mainly was dealing with the radicals. And just remember that the radicals have to be greater than or equal to 0. 6-8, you learned about the piecewise function, and then a little bit more work on the intervals of increasing and decreasing and constant. So I feel good because y'all knocked out a lot of them questions on that interval stuff. So good job on those, okay? So y'all, let's see. That means Thursday will be a pretty mellow day because all we got to do Thursday is our 5.4 section. Okay. So let me quit the recording.